spring 2020. I am one of the undergraduate teacher's assistants, Riley. I'm going to be talking about the assignment 3, specifically the Allen test case. So for Allen was one of the ones I had the most trouble with last semester, but fortunately I got through it, so I'll be talking about how to get through it today. So you will be getting your text file from Gradescope, and I imagine that you will have already gotten your test case. Each test case should be individual, and no two are alike. So I'm going to pull up my text that I'm going to be working with. Okay, that my text length is about, it should be 2,668. Selected is 2,670, but it's really 2668. So I actually blocked the text into different lines. It's going to show more because it counts the next line as a character as well. Over to the programming side of it to decode. So I put the string I got as a private static string in Java. This will have the 2,668 character limit as in just in one string, and I also made it an array too, in case I wanted to test individual lines itself. So we have the base 64 encoder and the base 64 decoder. Each of your strings should be first encoded in base 64. So you have to actually decode in base 64 first in order to actually get your ciphertext. So it will be encrypted using Vigenere or the Allen test, and then on top of that it will be encrypted using a base 64. So you have to first decrypt it with base 64 in order to get your text to determine the Vigenere. So right here I have a method that will take a string and put it in, we'll have a decoded ciphertext new text. This is important later, just base 64 format. So I'll just take a string, it'll create a buffered writer, it'll write the string and then close it, and it's going to be named decoded cipher new.txt, and it's going to pop up in your directory where, or if you're using Eclipse or however you're doing it, will pop up in the directory where the designated the project. So actually I'm going to name it decoded cipher, decoded base 64 version.txt. I'm going to save. So here we're just going to get the decoded string of the decode of the encoded string, which is going to be my string that I have. It's important to use new string because it takes each of these as byte arrays or it outputs a byte array using base 64. So you're going to need to do new string to actually bring it together into a string, and then then after that's done, it's going to output for me. So it just ran. I can reload this, and right here we should have it. So it's going to be like, it's going to turn out to be like kind of unreadable, but that's the point of it. So if we go over to the directory where it is on our can do here. I'll get that. Okay. So I now have the directory where it's assigned. You can open it up in normal Notepad, but I recommend opening it up in Notepad++, just because it was, for me, it was a lot easier to work with and manage. So we have our string that is now decoded from base 64 into what we can now look at using the Vigenere. So the first part of the Vigenere is checking for repetition. So I actually used a repetition finder online using like just like word frequency counter. Find repeats in text or duplicates. So let's see. So one of the ones I used last semester is actually this French decode website. It actually gave me a few different options to look for. It might even be okay. So we actually finally found something where I can get a count. So what I did is I marked them on the text, and then I looked at them individually. So actually, if we look at this, it actually extends farther. So right now we see that there are matches that we can look for. So we want to start from either the first or the last. So I'm going to do first. I'm going to highlight to the bottom where it is. And we actually get a selected count of 110. We have 110 as one of our numbers that we can find factors of 110. So 2, 5, 10, etc. So what we might want to do is start writing down numbers for this. So we'll take this string, and say we have 110 as the length between two of them. Then we can go here. We can go here to here. That's 160. And we could do here to here, and that's going to be 270. And if you can save it if you feel like it, if you want to. So now it matches, so we can mark those, and we can see that VT sin J actually pop up here. So we can, let's see if we can mark those. See that the string is long enough to like be sure. It doesn't really matter where it is, but like the mark, you just got to get first to the next one. Okay, so we can just copy this string, and if I remember correctly, we actually got a number of 110. So we can actually begin this. So out of 110, we have, okay, so let's just stick with the base factors here. Actually, we might like to do 2, 5, and 11, but 11 won't pop up in 270, so we can actually disregard that, but for the case of making sure that we're thorough, we can do so we're going to exclude 2. We have 2 pops up, 4, 5, 8, 10, 2, 7. So 2, 2, 3, 5, 10, 9. Well, actually 9 pops up here, but another thing we want to keep in mind is that the factors of numbers like 9 and 10, so like 2 and 5 will actually be in 10, 2 and 2 will be in 4, 3 and 3 will be in 9. So really we kind of want to look at more of the factors of the numbers. You see that actually 2 pops up for each of them and 5 pops up for each of them. So what we can say is that so we can try that our key length is 2. We could say it's 2. We can try using 2. 2 is actually a number that we can brute force actually pretty easily. So we can force key lengths of 2. 2 is an actually pretty easy number to brute force. So what I've made 2 methods and then 2 constants. I can actually put fine on these and that'll be fine, but for that. So we're gonna assume that the key length, it can have a space in it, so we're gonna go from values of space to the next, or to the last value that it could be, and that would be the tilde, and which has a decimal value of 126, but it is 7e in hex, so we'll go with that. So here we have, so this method just permutes it. This is a recursive function in order to try different keys of the specified length. So it's going to print if the string length is what we want, so 2 in this case, and then it's just going to recursively build upon that and so forth using the functionality I have described here. So the character is going to be the character of the byte value I, then it's going to add that to the string. At the beginning it's empty, it's going to permute it, and it's going to actually add it again and then permute, then it's going to actually come out to be 2, exit, and then it's going to remove that last character and then keep going with the recursive loop, or I'll go back to the for loop, start again, keep going, and so forth. So we're going to so right here I have key length of 2, and we're gonna try and see if we can get the key value of 2. I didn't want to do all of it, so we're gonna do encoded strings of, we're gonna do my encoded array of strings. So we're gonna do 0. Actually we can do, this obviously doesn't look like it's anything helpful. So there's kind of a bit of like looking through the text to see if there's anything that like pops up that is remotely English. Let's see. We can keep going through this, but we could also try common words like the. We can try using words like the. So it pops up here, but I mean, it could pop up anywhere. We could do spaces. I mean, there are plenty of spaces, so, but clearly the text, if we go through this, there isn't very many patterns that are popping up. So you can still keep going. Obviously there's different like amount of lines going on, but really nothing that really says that the key length is 2. So we could actually have this run with 5. However, we're gonna have really take a day. This wasn't a very strong method to brute force. I'm gonna need a different way of doing this. As we can see, another way we can do this is by employing grammar rules. For example, if we take a look at letters, letters are usually only followed by other letters or punctuation or a space. So it could be like this, just ME or a period, so me, then AA space A, that works, AA question mark, and then AA colon, etc. Numbers could have a letter after it, or any letter punctuation rules. So 1A right parenthesis, probably not going to have 1A left parenthesis, so there could be some other grammar checks you can implement to do it. However, numbers usually don't follow letters without a space after. So, I mean, me too doesn't make sense in a sentence. If we're taking regular sentences, it usually doesn't have that. So, but if you had like yes please, that would pop up, but yes please 1, where 1 is right after the E on please, that it just isn't normal or normal for English. So you could also look for that. So I have a dummy string. This sentence is had a cat before me, had a coat. So if I had the key A, B, C, D, E, had, and had on the first part, and then the fourth part match up, but after D, E, it does not. So we would you can change D and E at the end of A, B, C in order to match with the rest of the sentence. So you could build upon that. You could brute force those last 2 characters actually in order to get the key that way. So it's kind of building upon each other depending on how far you get into your key build.